What's up guys, Onmaths here, and we're looking at construction and loci. So first question from AQA, it says the front, side and plan of, or elevation and plan of a solid are all the same and they are all squares. Write down the name of the solid. So if you imagine it, I can try and draw this in 3D as much as I can. This shape here would have a square front elevation, which is this one. So if you looked at it straight on, it would be square. If you looked at it on the side, it would be square. If you looked at it directly from above, it would also be square. And that shape is a cube. Right, next one. Same deal, but this time it's a circle. And there's no edges, there's no points or vertices on it at all. And the only shape I know that looks like a circle anywhere you look at it is a sphere. Now you do have to be careful with this. If on question A you wrote cuboid, but it's drawn to scale and that is a square, so they're equal lengths, so it has to be a cube, not a cuboid. Similarly with this one, if you wrote, for question B, if you wrote ball or something like that, you wouldn't get the marks. You've got to use the mathematical names for it, which are cube and sphere. Right, next we move on to our Edexcel question, and this time it asks us to draw the front elevation and the side elevation. So the front elevation will be, well, from where the side it says front, so it will be this bit here, all of this bit here, this side here. Okay, that is really bad shading. Let's try a little bit better shading. So this bit here. Okay, and remember this needs to be two-dimensional. As soon as you draw a little bit of a 3D line for artistic purposes, you will lose your marks. Okay, so it has to be a 2D representation and it needs to be to scale. So if we have a look at the question, it says 2 centimeters to 1 meter. And this is a centimeter grid. It does say it's a centimeter grid. So 1 square is worth 1 centimeter. A lot to keep in your head, right? So the first thing to do is just start on a point on this grid. I'm just going to start from the top left. And the first thing I'm going to do is draw, if I can get it straight, this line here. That's 2 meters, but it says use a scale of 2 centimeters to 1 meter. So I need to do 2 squares for every meter. So that would be 1 meter, and that would be 2 meters there. So it's going to be 4 squares. It's going to go across 2 meters. So it's going to go across 4 squares. It's then going to go up half a meter. Now half a meter would just be 1 square. And then I always save the diagonals till last, because with the diagonals you just join up what's remaining. I'll need to just make sure I label it, show the examiner that that's the front elevation. You could write front or front elevation. Okay. Next thing we need to do is we need to do the side elevation. Now side is where the arrow is pointing, it says side. So you'll definitely see this bit here on the side elevation, but you will also see this bit here. So it's all of this what you'll see. Okay, so we need to somehow draw all of that. Okay, so where shall I start? Let's start with the harder bit. So when you're standing there at the side, you will see this bit and you will see this bit, but they'll just look like one straight line. And looking at the height here, it says the height is 2 meters. So the height of this will actually be the same. So we've got our 2 meter height there. Okay. This bit here will be 1 meter across, which on our scale is 2 squares. Simple as that. That's a nice easy one. The next bit, this bit here, will basically be the same as the other side. It will just be 2 meters tall. It will look 2 meters tall, and then join up the rest. There we go. Now there is a part I'm missing here, and you will lose marks if you don't draw it. Any joins, any changes at all, you need to show. Okay, so we need to show that line there. Now that's 0.5 meter from the floor, which on our scale will be 1 square. So it's that line there. You must show that line. Now I'll reiterate this. I know I've said this, but the second you draw any kind of 3D-ness on it, the second you do that, you will lose marks. I wouldn't also bother kind of shading it in at all or anything like that. It's not worth the time. Just draw a nice outline, and when you shade it in, this line here might not show up as well, and that's really important that you have those lines showing well, otherwise you will lose marks. And let's also just label it as well. Our final questions from OCR, and this is kind of the question I've been dreading, because this is really difficult to show on a video like this, but we're going to try our best. So it says that the diagram shows a scale drawing of a park, and 1 centimetre represents 10 metres, so we'll probably need that for later. The first question says a straight water pipe runs across the park, and the pipe runs equidistant from DA and DC. Now equidistant just means that at all times it is the same distance between the two of them. Construct using compass and ruler only the position of the water pipe. Okay, so this is where this becomes a bit more fun. So I've got my fake compass in front of me, and I'm going to talk you through it, but I'm obviously not going to be able to show the drawing of the drawing of it, but we'll try our best. So we're looking for the pipe to be equidistant between the line DA and the line DC. So what this is essentially asking us to do is draw a line that bisects that angle. Okay, so if you want to look it up in a revision guide, that's what it's called. It's going to be bisecting the angle. We're going to start by getting our compass, and we're going to measure. We're going to put it about, or just over halfway, probably 3/4 if you can. Mine's going to be a little bit shorter than that, of the distance between D and A. So get your point, put it at D, and just stretch the compass out so that it's over halfway the distance between D and A. Then you're going to just draw an arc. An arc is just a bit of a line from D, so get your point at D and just draw the arc like so. Okay. Now, these 2 points here are points we're going to use to draw another arc, another 2 arcs. Okay, so I'm going to put my compass at the point I've made on D and A, and I'm going to draw an arc up here. Then I'm going to do the same at the point I made between D and C, and I'm going to draw an arc. Oh, this is what happens when I'm trying to use these kind of fake compass. It slips. Hopefully your compass won't slip as much as mine has. Right, those 2 arcs we've just drawn, they will intercept. Okay, and you mark that point. And what you now do, and this is the important part, is you get your ruler and draw a straight line between D and where those points intercepted, and you can just keep going. Now we're only interested, I think, in where it runs across the park, so we can stop where the park finishes. Okay, now those green construction lines are what gives you the marks, so don't rub them out. You need to leave them on. Show the examiner that you first of all you identified these 2 points here, and you don't need to show the points. I've just used that. The blue crosses I've just shown to illustrate what I've done, and then the other 2 arcs as well. So that's how you get full marks there. That's our pipe. Right. Question B says a straight path connects the entrance to the exit, and we do actually have the entrance shown here. So the entrance is here, but we don't know where the exit is. So construct the position of the path knowing that the path is perpendicular to CB. Okay, so we need to draw a perpendicular line. So we're going to do the same thing. we're going to use our compass, and we're going to put it at C, and try and pull it out to about 3/4 of the distance between C and B, and draw an arc. Now I only need to do that part there. Okay, you can draw like a full semicircle if you want. You don't lose marks for drawing too long an arc, but keep the same distance on your compass, and that's the important thing. Okay, keep the same distance, and what we're going to do is draw another arc from B, like so. Okay, where those two have crossed is the point we're looking for. Okay, where those two have crossed. And what we're going to do is we're going to get our ruler, and we're going to start the entrance, and we're going to keep going, and we're going to go through where the two arcs have crossed, and you can see here clearly that this part here is where the exit is. Now, is that at right angles? Yep, that is. And again, the red lines we've just drawn, the construction lines, are what gives you the mark, so make sure that you have those construction lines there. Okay, and it says leave all your construction lines on both of these questions. Okay, just to remind you. Last part says find the actual length of the path in meters. Now, this is impossible for me to answer because I've scaled this up so that it shows nicely in this video. But if you were to do it on the paper, so if you went to the OCR 2017 November paper, paper 3, and had it in front of you, you'd find out that this path is 12 centimeters long using your ruler. Okay, so you'd be tempted to write down 12 centimeters. However, this is where that scale comes in. Scale says 1 centimeter represents 10 meters. So all we need to do here is get that 12 centimeters, times it by 10, and that would be 120 meters. Now there's always a bit of leeway with these things because when you constructed the path, you might have not got it perfectly through those arcs, so there's a little bit of leeway on this, but not much. I think you can have anywhere between 118 and 122, so you've got about 2 or 0.2 centimeters, 2 millimeters of leeway with your measuring there. Well, I hope this video has been useful. If it has, please click like. If you want to see more from us, we release videos every single weekday, Monday to Friday. So just click subscribe, make sure you're up to date. If you want to see more from us, go to our website, onmaths.com. There'll be a card that magically appears at the top of this video now. The website has loads of free resources. You can even sign up for free to save your scores and have access to our summer school. Thank you very much, and I'll see you tomorrow.